Hello there, I'm Eric. Welcome back to the Together Learning Digital Literacy series. And today we're going to talk about color, mainly how to represent color digitally for purposes of making digital images or producing websites, and to help understand color so we can represent it and have it more aesthetically pleasing for those purposes. And so, I'm Eric. I'll be your host for this short session, and this is Together Learning series. All right, so this is our visual spectrum of what we see colors as. It's very large, long wavelengths here, short wavelengths here, and all we can see is this little span of light, which makes all the colors of the rainbow. And what artists and painters have done long ago is made something called the color wheel to help us represent it, and those visible colors loop back in on themselves, connecting. And we use this wheel in various ways to represent color and to match color and to make color schemes um, on websites and images. And we use this to make perhaps things warmer and cooler, right? And we have filters on our Instagram and whatnot, and we can shift things from warm to cool. Movie makers often shift the colors that's happening in a scene of a movie, more warm or more cool, to make us feel different ways. Different colors have, different things attached to them depending on your culture or where you're from. Like green might be nature, or cool might be calm. Orange and red are usually active or love. But cool and warm represents these two kind of sides of the color wheel, and that's one way that we use the color wheel to help us understand and use color and mix and match them for digital purposes. We also have these color schemes that we get out of the color wheel, right? On the opposite end of any given color is its complementary color, which is its opposite color, right? These colors stand out from each other. They're high contrast colors, right? And we can go 25 degrees in either way, or we can go across the complementary colors and go mix the ones adjacent to them, and we get these color mixtures that we see here, right? Very different colors, colors that are close to each other. And we can use these color schemes for templates on a website, or to when we're designing some sort of image, digital media, maybe a print marketing image. We might be able to use these schemes to make something a little more aesthetically pleasing, or maybe make a text more pronounced so it jumps out at you. If we want someone to really notice some particular part of an image. There are two different ways we can think about mixing colors, and that's Rgb and Cmyk. RGB, red, green, blue. Cmyk, cyan, magenta, yellow, black, right? Mainly, RGB is used for digital purposes, right? Mixing them together to get more colors, or taking out colors to get different colors using the print media. So if you've ever used a digital printer, you usually have these colors of ink inside your printer, and mixes them together to give you a nice range of colors on your printed page. But for digital purposes, we're using RGB. So I'd like to talk a little bit about how do you represent a color via a computer. How do you represent a color with computer code so we can use it in HTML or CSS, or better understand how a computer is displaying color, or maybe pull out digital color from an existing image so we can duplicate it and use it for different purposes. Right, so we're using something called hex, which means hexadecimal. Hex comes from hexagon, right? 8, 1, 2, 3, 4, 5, 6, 7, 8. And usually, computer is in binary, which is 1 and 0, but hex is 8, so we have binary, our 2 off and on, to the 8th power, hex right? 8. And we get 256. So we have 256 possible colors. But that doesn't seem like a lot, does it? So what we did is created this range, this hex range, one for red, one for green, one for blue, because the technology used on your screen uses these red, green, blue to display colors. So we have 256 possible reds, 256 possible greens, and 256 possible blues. And we can mix them all together to represent almost any color possible on the internet. So, we're not just dealing with ones and zeros. These are represented in a hex code, which is 1, 2, 3, 4, 5, 6 characters long, starting with a hashtag. And this represents all of the possible colors in the rainbow digitally. And each one of these digits can be represented by a number or a digit from 0 to F. And this is 16. That's 8 times 2, right? 16. So 16 times 16 is 256. 256, 256. So we get our 1 through 16. So we have 0 through F. A, B, C, D, E, F. So how does that work? So 0 is no color, and F is everything on. So it's like a intensity, right, of each color. So if we want a specific color all the way on, or on maximum, it's F, or it's not on at all, it's 0. How would that might work? Let's take a look. So we have 0, what we have here, 0, 0, 0, 0, 0, 0. So off, no red, no green, no blue. And everything is off, there's no color being put out. We're going to have black. No red, no green, no blue. It's all off. So we have no color. Absence of color is black. On the opposite end, what if we did the opposite? F, which is all the way on. All red possible, all green possible, all blue possible. What kind of color do you think we'd get out of that? Well, if you said white, you're correct. White is the opposite of absence color. It's all colors, and white contains all other colors. So we turn on to the maximum value of red, green, and blue, and we get white. How about this one? Well, it should be quite easy because we have red all the way on, and the other colors are off, so we have red. Here's some examples of some other hex codes, right? So this looks reddish, but it has some other colors mixed in, right? 5, 8, 5, 1. So you have like a pinkish magenta hue here. Here's a yellow, the mixture of colors here. 0, this one's all up, very black. So you notice these are low colors, right? Very close to 0, low numbers, I mean. So 1, just a little bit of red, little extra red on this one. 1, B, 2, 0. So it's very dark color, right? We have F, something, there's one red that's all the way on for that one as well. So in total, we could have 16 million colors in this hex code and combinations therein. If you want to play with that, if you go to togetherlearning.com, we can see some examples and play around with color schemes. So here's our basic color and our HTML, CSS, RGB, right? White with all Fs. Let's take a look at this color calculator. Right, so just to take a look and see how this might look. We have FFFFF, so we're right there in the middle. We have all the colors on, right? We got white. And if we're going to move around, we get the colors represented here, purple. You notice how some turns all the way on with F, and some goes off with 0, right? So we're going to go around here, and then some turn F. So maximum color on the edge, absence of some color on the edge, and all maximum possible colors towards the center. So we're mixing more as we get towards the center. And we have a whole rainbow of colors, combinations, through this little diagram here. Now, you can see the opposite on the complete opposite end of air. So we can get the opposite of this lime green is this very bright pink, the complementary color, right? And we can use things like this to help us have colors pop out at each other. These are direct opposite colors. You can have sort of harmonized colors together, different shades of colors, different intensities. Analogous colors, where we group them together a little bit further apart. Personally, I like intense colors, so we can go down here and make them a little less intense. Here's our split complementary. So the complementary is on the opposite side, but we're not taking that direct color, but one's next to it, and so on. If you want to go back to togetherlearning.com, you can see a whole bunch of other things to help you play around with color. You can pull out digital color and find out their hex code, and then you can replicate that in different digital software. All right. This has been Eric for Together Learning, talking about digital color. We'll see you again next time.